Okay, in this video I'm going to go ahead and show you some more Class C network subnetting. And in a Class C, we've got 3 bytes of our IPv4 address, our network bits, and before we subnet, we've got 1 byte worth, or 8 bits of host bits, which label the hosts. Okay, and I'll go ahead and use the example of the private 192.168.10 subnet Class C network, and now we're going to subnet this. Okay, what we're going to do is we're going to take some of these H bits and turn them into subnet bits. Okay, and in the previous example, what I did was I said, okay, let's take this Class C network and divide it into 4 subnets. And I did that by setting S equal to 2 and H equals 6. Okay, so I take my original 8 host bits, and now I'm going to divide them up into 2 plus 6 host bits. And in this case, we'll have 2 to the S is the number of subnets, and 2 to the H is the number of IPs per subnet. Okay, and it takes us all the way back to this table here, where I'm showing, starting before I subnet, all 8 bits in the last octet are H bits. I can create 2 subnets by using 1 S bit, 4 subnets with 2 S bits, etc. And so what I'm going to do now is just make a table that shows how we're going to divide our network, all the different ways we can divide this network up into subnets. So what we'll do is we'll say that we have various S values that we can use. We can have the number of subnets, which is 2 to the S. We'll have some number of host bits left after we steal some of them, and we have the number of IP addresses per subnet. Here, I'm going to make a table of all the different possibilities. And if S is 0, I only have 1 subnet, and I haven't really subnetted yet. I've got all of the original 256 IP addresses available from that last octet. But if I go ahead and set S equal to 1, I'm going to get 2 subnets. H is now 7, and I get only 128 IPs per subnet. 2, 4, 6, 64, and so on. When S is 3, the number of subnets is 8. I've only got 5 host bits left, and 2 to the 5th is 32. So the number of IPs per subnet is, let me notate that here, is 2 to the H in our table here. Okay, I can steal 4 bits, and I'll have 16 subnets. I'll only have 4 bits left. I can steal 5 bits and get 32 subnets. Only 3 bits left, only 8 IPs per subnet. And finally, I can steal 6 bits to get 64 subnets, each of size 4. And that's about as small as we can go. Why 4? If we go down to the point where we have, to the next level, where we have only 2 IPs per subnet, then those 2 IP addresses are really just the network subnet ID and the broadcast address for that subnet. And it doesn't really leave us any IPs to use for hosts. Okay. So these are all the possibilities that we have in subnetting a Class C network. Okay. And the typical thing to do is, just as I showed in the previous example, the typical thing to do is to take those subnets and write down for each of them the subnet ID and the subnet broadcast address. Okay? And when we're subnetting a Class C network, All the action is in the 4th octet. And so we're always working from the range 0 to 255 in the 4th octet. And so what you'll see here then is that this number 64 is an increment. We're literally counting by 64s. 0, 64, 128, 192. And if we count by 64s, we're going to get the 4 subnet IDs for the case s equals 2. If you want here, we can write down what is the increment for creating the subnet IDs. But the increment is really just the size of the number of IPs of the subnet. It's really the same exact number. So here, this third row, where S is 2, H is 6, 64 IPs per subnet. 64 is exactly equal to the increment. 0, 64, 128, 192. We've counted by 64s. And so you can see that you just count by 64s to get the subnet IDs for a case of S equals 2. You count by 32s when you divide up into 8 subnets. You count by 16s when you divide into 16 subnets. You count by 8s when you divide into 32 subnets. And finally, you simply count by 4s to get all the network IDs. Okay? So we can get all the network IDs, or the subnet IDs, let's call them, by using the increment value. And the increment value in this case, again for class C subnetting, is just equal to the number of IPs per subnet. Okay? And so this gives me sort of a shorthand way of writing down all the subnet IDs. How do we get the broadcast addresses? The broadcast addresses, each is one less than the next subnet ID. And we can see that back here, where the broadcast address of the first subnet is .63, which is one less than the .64, which is the ID of the next one up. Similarly, 127 is one less than 128, 191 less than 192, and at the end we have the 255, one less than what would be the next number, 256. Okay, so, for example, I can divide the class C network, 192.168.10.0, into 32 subnets. Well, let's do 16 and find the subnet ID and broadcast of all of them. Okay? That's 32 addresses altogether, but we can do it. So what we're going to do is we're going to count by 16. Let's see, 16 subnets. Let's be careful. Means that 16 subnets means that H is equal to 4, since 2 to the H is 2 to the 4th is 16 is equal to the number of subnets. I'm sorry, it means that S is 4. Hold on, let me back up here. We're counting number of subnets, and that's given by 2 to the S. This is very easy to do, is to use the wrong one. It means that S is 4 since 16 is equal to 2 to the S, which is 2 to the 4th, which is the number of subnets. And I'm going to call it the number of subs. Okay, and that implies, therefore, that H is also 4. And this is the case where we have 4 and, or we have 4 and 4 for both S and H. And so it's 16 subnets, each of size 16. So we get two 16s here. And that implies that our increment, which is equal to the number of IPs, is 2 to the H, which is 2 to the 4th, which is also 16. So 16 subnets of size 16 each. And we can now go ahead and write down 192.168.10.0 is the network ID of the first subnet. And I'm going to write down the IDs. .16, .32. I'm going to count by the increment. .48. I'm going to count by 16s. Dot 64, dot 80, dot 96, dot, what's 96 plus 16? 112, dot 128. Hey, that's nice. We land on the 128. Okay, so this is the ID of subnet number 1. This is the ID of subnet number 2, ID of subnet number 3, ID of subnet 4, 5, 6, 7, 8, and subnet number 9. The broadcast addresses are 31, and right away I'm just writing the dot of the last octet because the 192.168.10 is the same throughout here. Okay, it's very common to do that. And I'm also not repeating sub number everywhere here, and I'm not even repeating the 3 dots. Okay. Dot 31 is the broadcast of number 2. Dot 15 is the broadcast of subnet number 1. See if I can fit it all in here. I'll draw a red line right above all of our subnet IDs so we have room for a broadcast address right underneath the ID. I know it's kind of tight here. Okay. And I'll draw the broadcast addresses in green. Dot 63, 1 less than .95, .111, .127, and .1. What's the next ID? 128 plus 16, 130, 144. So this would be a 143. Okay? Okay, so these are the broadcast addresses of these first 9 subnets. First 9 out of 16. And I can continue on then and continue on to the next broadcast address, which is that 144. 192.168.10.144 is the ID. Okay. And this is going to be subnet. This is the ID of subnet number 10. And I'll leave myself room for number 11, 12, 13, 14, 15, and 16. And you'll see that if I count by 16s, I really will land up at the 255. 160 is going to be the ID for subnet number 11. 44 plus 16 is 60, right. 176 for number 12. 192 for number 13. 192 plus 16 is 208 for number 14. Dot 224 for number 15. And dot 240 for number 16. Okay? And in every case, the broadcast is 1 less than the subnet ID of the one above, of the next one up, .175.191.207.223.239 and .255, again, one less than 256. Okay, so this is how you can argue, starting from the fact that we start with a class C and that we want to divide it into 16 subnets. From 16 subnets, we deduce that S is 4 because 2 to the 4th is 16. And we started with 8 H bits in the last octet. If we steal 4 of them to be S bits, the new number of H bits is 4. And 2 to the H is also 16. So I have 16 subnets, each of size 16. The first subnet ranges from 0 to 15. The second from 16 to 31, just as you would imagine dividing up a number line into of length 256 into lots of little pieces. 64, if we divide it up, 192, 32, 96, 160, 224. And if we divide it up again, we'll see all these numbers that we've got. Okay? And so we're literally just dividing the number line up into little chunks of size 16. And they give us the subnet IDs and the broadcast addresses of all those subnets. Okay? And I hope that you can see that we can then take this table and use it to divide a Class C network up into any size we want. We can divide it into 2, 4, 8, 16, 32, or 64 subnets. Obviously, it gets a bit tedious to write all the subnet IDs out of all 64, but you can do it if you count by 4s, which is our increment value. Okay, hope this helps.